If you click that, you'll be able to move the interpreter around and have our interpreter in a separate window. We also have a live cart captioner here, so be sure to click the CC button at the bottom of your screen, and that'll enable live captions throughout today's call. If you have any questions, please use the chat to ask us. And in the meantime, maybe you can use the chat to tell us where you're tuning in from. We'd love to see where everyone's calling in from and hear from all of you. I'd also like to thank the SETI Institute for live streaming today's event. Thank you so much for helping us reach more people and share the important work that we'll be talking about today. So speaking of coming from around the world, we have a very international team here. So I myself am actually currently in South Africa at the International Astronomical Union's General Assembly. It's the very first time this international astronomy meeting has been hosted on the African continent, and we are so excited to have about 2,000 astronomers here in Cape Town. And I want to give a big shout out actually to all the students I just met from the Diasville High School in Saldanha and at the Expo for Young Scientists. We just had the privilege of meeting basically the next generation of scientists and explorers who blew me away. And so it's just a real privilege to get to go there and learn about and teach a little bit about what we're doing in astronomy and in the sciences in general. So really excited to have that connection with us today. And with that, I'm going to turn it over to my colleague Sheila to introduce herself. Thank you.
All right. Hi, everyone. My name is Sheila Zhu. This is my sign name, and I am a Deaf AstroAccess Ambassador. So, I'm sorry. Yeah. Oh, let me see. Hold on. Let's join the audio. All right. So let me back up. I'm also the Deputy Director of Development for AstroAccess. I recently graduated with degrees from Harvard and in public policy and business from Wharton. I specialize in researching multimodal communications and human space exploration in order to find alternatives to radio communication. I am really, really thrilled to be here today and share our work with you today.
Thank you so much, Sheila. Over to Pascal.
Good morning, everybody. My name is Pascal Lee. I'm a planetary scientist with two nonprofits, the SETI Institute and also the Mars Institute. I'm also a professor of planetary sciences at Kepler Space University, and I'm based at NASA Ames Research Center in the Bay Area. I'm here today in the Arctic at our base camp on Devon Island. And I have some background information to share with you first about our project. But I did want to say up front that I'm super excited about this, what this event is gelling, which is a partnership between the Haughton-Mars Project and AstroAccess. I think AstroAccess, what you guys are doing is amazing work, and we want to be part of it. So thank you for the opportunity to join forces here and hopefully enable more people to go to space, but also to come prepare for future planetary missions in the Arctic with us.
Fantastic. Thank you so much. We are so excited. And with that, we will share a little bit more about the background on this work. I also just want to take a moment to acknowledge, thank you everyone in the chat, sharing where you're calling in from. We have all the way to the Arctic with Pascal, Sheila in Italy. I see Scotland, I see United Kingdom, Israel, the Ohio State University. So really great to have everyone tuning in from all over the world. So to kick us off, for anyone who might not be familiar with the AstroAccess side, Sheila and I are going to give you a brief overview about what we do and why we're excited for this new partnership with the Haughton-Mars Project, and really what that means for next steps when it comes to breaking down barriers to access to human space exploration for everyone. So, as I mentioned in the beginning, I am the director of a nonprofit called SciAccess that has actually sort of 4 key branches: networking through an annual conference focused on disability access each year, outreach through a series of different public programming, including Solstice, a portable planetarium show, mentorship, which we work very closely with the Ohio State University on to mentor blind students interested in astronomy. On that slide, I have a picture of a 3D printed galaxy, which I'm also holding up to the screen right here that we've created. This one was in partnership with the Space Telescope Science Institute to make science more accessible for blind learners and really all learners. And last but not least, research. How can we be doing active research that really moves the needle when it comes to disability access and what we call universal design, designing for the widest audience possible to benefit all people? And that's what we're going to focus on today through the AstroAccess program. We've been really fortunate to have received awards for this work on the global and national level, including the NASA Space Tech Catalyst Prize this year for our work in best practices with diverse researchers and to contribute to NASA's ongoing efforts to find creative solutions to technical challenges. We're also a recent winner of the Haughton Prize, which is the highest honor bestowed to an organization by the National Federation of the Blind, and the Falling Walls Award, which is an international prize for science engagement excellence. Our vision is this idea that if we can make space accessible, we can make any space accessible. And so what I mean by that is we're not just thinking about space, but we're also talking about how that can benefit people's lives here on Earth. And this goes back to that concept of universal design on our planet and beyond it. How can we be thinking about accessibility in our day-to-day lives and in our space systems, our space stations, our space training facilities? What does that look like, and how can we use accessibility to improve experiences for everyone? Ultimately, we see this as a way to break down barriers to fly disabled astronauts to space, and in doing so, ensure that the 15% of humanity, and we know it's actually more than that, unreported, who have a disability aren't excluded from this next generation of exploration. And in doing so, we see this as a real opportunity to be shifting global perspectives about disability here on Earth and providing that critical representation that people need to know that there's an opportunity for them to go into these fields and to contribute to that process of discovery. So I mentioned these statistics. The latest shows 16% of the world population, 27% of the United States population, and 46% of the world population ages 60 and up. And as I mentioned, this is just what's reported. So we know these numbers are actually much, much higher than what you see here. So we're talking about the world's largest minority group, which historically has not been given the same opportunities when it comes to space exploration. And that's what we're here to change. And the way we've been doing that is through a series of research projects. So the kind of key center point of a lot of this work to date has been through a series of parabolic flights. So this is a regular aircraft that goes up and down and repeated parabolas. And at the top, you get about 30 seconds of weightlessness. We've performed these flights with the Zero Gravity Corporation in the United States and selected what we call our AstroAccess Ambassadors. So these are individuals such as Sheila, who have been competitively selected from around the world to fly with us in zero gravity in order to design and execute experiments and demonstrations that really advance accessible design and change physical environments aboard space vessels. To give you an example of what I mean by that, so to date, we have completed 7 zero gravity missions since our founding in 2021. So we've been very busy. We had 2 large scale missions with the entire plane. And then we've had 5 partnered flights where we've been invited as guests aboard other flights, such as the O'Reilly Institute and our collaborators at MIT. Here I have an image of Dina Lambert, who is a NASA employee as well as one of our ambassadors. And she's one of the members of our blind and low vision team. She's testing out tactile graphics aboard one of our zero gravity flights. Because if there's an emergency in space and the lights go out, or if there's a fire and smoke and people can't see, having tactile ways to navigate is just a better design, is a safer design. So again, we go back to this idea of how can accessible design just be useful for everyone. We also did seat docking demonstrations with a 5-point harness designed to replicate the harness of a standard suborbital space flight vehicle. And we had ambassadors with mobility and vision disabilities successfully demonstrate that, yes, they can independently don and doff that harness and be able to perform that key task. I'm going to turn it over to Sheila now to talk a little bit about this last slide, because you may not be able to tell, but that's her upside down in this last picture. So Sheila, I'd love to turn it over to you. Thank you.
Sure, I can do that. Let me get situated here. All right. As you can see in that picture on the right, I'm inverted. And so this was me and my deaf colleague named Eric. We were testing out signs and sign comprehension and legibility in various orientations in 0G. And what we found out was that as long as we can have eye contact, we can understand each other clearly. And I did want to add, if you see the green light in the background of that picture, that was our accommodation light experiment. So what we did was we had the lights change as a warning as we were in different phases of our parabolic flight. And holy cow, did that not only help us, but that helped everybody, because that plane was super loud, and it was a really, really good example of how accessibility benefits everyone.
Thank you, Sheila. Really great points. Because you're also featured in these next slides, Sheila, I'll let you take over here and tell us a little bit about what's going on with these analog trainings.
Sure. For the analog astronaut trainings, I mean, I'm sure a lot of you are probably wondering, what are analog astronaut trainings? What they are is a training program where people live and work in conditions similar to space, but they emulate it here on Earth in order to get ready for real space missions and to test new ideas and equipment and various experiments. So in all these pictures, it shows you 3 out of the 4 analog astronaut training experiences we've had at Biosphere 2, including people who are deaf, blind, and have mobility disabilities. As part of our work to investigate how working and exploring space can be made accessible. So an example here is that there's a spacecraft, say it were to land in the water. Could we egress safely? Or say there was a fire in the capsule, could we egress safely? The answer to both of those is a resounding yes. And then in this last picture on the right, we have Sherry, a blind researcher, successfully carrying out soil samples in a simulated lunar field. So because of these analog missions, we have been able to very, very confidently prove that people with disabilities can be successful and safe as a space explorer or astronaut. All right, next slide. Perfect. So, sign language communication in space, especially in a spacesuit. So we tested this, as you can see in the video, at Biosphere 2. And my deaf colleague, Eric, and I, we made history as the first people to communicate through sign language in a spacesuit. And it's probably the first documented time that's ever happened. So with that being said, what I noticed was when I put the helmet on with my cochlear implant, I wasn't able to hear anyone talking outside the helmet. And I was talking in the helmet, and people outside of it, hearing people outside of it, couldn't hear me. But my colleague and I, Eric, we were able to sign without any problems. Well, for the most part. The gloves were a little stiff and a little thick and a little bit too big for me, but we could still communicate. And it's a great opportunity for spacesuit improvements in the future. Probably hand legibility for communication as well as manual work. So I think it would help not just the deaf people, but everyone with dexterity.
Thank you, Sheila. I'd also like to mention here Uplift Aerospace, who helped sponsor this mission. and University of Arizona, as well as SAM at the Biosphere 2, all of which were partners in these various past missions. And I really think all of this work we've been doing, from the missions to the zero gravity flights and beyond, in my mind, is really culminating in what we're talking about today, leading up to something huge. And that's this new partnership with the Haughton-Mars Project. And I love this photo. Right now on my screen, I'm showing just this amazing aerial view of where Pascal is as we speak. You'll get to learn more about that soon. But it's otherworldly, but it's right here, on our home planet. And I think, to me, this is also just symbolic of the wide open field of opportunities before us, seeing this expansive image. And that's just something that I'm so excited to get to pursue and to work towards access together. So one of our goals right now that we're actively working towards is to be able to fundraise, to have some of our AstroAccess team members be able to join out in the Arctic Circle's Haughton-Mars Project site next year to really look at accessibility and also help pave the way for future inclusive opportunities for disabled researchers, scientists, and visitors in this truly unique Mars analog environment. So that's really our current project goal right now, is to be able to take that next step together and really see what can be researched when you have the exceptional resources and environment that the Haughton-Mars Project so uniquely holds. And in doing so, we see this as a way to not only make history, but continue to change the future of accessibility with this growing team and a growing partnership. So with that, I'd love to encourage you all to reach out if you have any questions on the AstroAccess side. If you'd like to donate to help get us there, please feel free to scan the code here. We'll also share these in the chat, or if you want to volunteer or learn more, please reach out and we'll share those in the chat as well. And while we're doing that, I'd love to turn it over to Pascal to give you a more behind the scenes look and in-depth information about what's happening in the Arctic Circle. Thank you.
Thank you. Thank you, Anna, and thank you, Sheila. Great introduction to all your good work. So I'm going to give you a short presentation on the Haughton-Mars Project. Then I'd like to introduce you to some of my colleagues and friends up here who know about your work and are very excited about you joining us in the years to come. And also, we'll end up with a tour of camp, which might be a bit of a letdown because we have foggy and windy weather today, and it doesn't look as Mars-like as it should. Oh well. So let me share screen, and this is a quick presentation on the Haughton-Mars Project. Do you see this?
Yes.
Okay, so the project is named after Haughton Crater, which is a meteorite impact crater. And let me show you where it is. This is where we are. As Anna said, we're inside the Arctic Circle. In fact, we are even farther north than Point Barrow, which is the northernmost point of the United States in northern Alaska. And we're in this corner of the Arctic, which is actually exceptional climate-wise because it is cold and dry. It's relatively dry. It's raining today or foggy, but overall, on an annual basis, we're in a polar desert. So this is drier and colder than tundra or taiga. This is polar desert. And there's not a lot of polar desert on Earth. There are the mountaintops are polar deserts. Antarctica, most of it is a polar desert, but it's also mostly ice covered. Whereas Devon Island has both ice covered land and bare land. The other thing is Devon Island, where we go, is the largest uninhabited island on Earth. So that has to count for something. And then on it, the main attraction for us is Haughton Crater. It's a giant meteorite impact crater that formed about 23 million years ago. It is 20 kilometers in diameter. And here I show you a view of Haughton Crater looking towards the north, taken from 10,000 feet of altitude, where we've added the Eiffel Tower, which is not actually there, but in Paris. This 20 kilometer diameter impact structure, which is just really stunning in this landscape. And our research base is set up right on the northwestern rim of it. where it says Haughton-Mars Project Research Station. We figure this crater formed when an object, maybe a comet rather than an asteroid, hit this site about, once again, 23 million years ago, but it was about a kilometer in size and possibly 20 kilometers per second in terms of its incoming speed. So that gives you a sense of the energy that was developed during the impact event. It took about 10 seconds for this crater to open up and form. It would have been an amazing view, of course, to be there. But this is our base camp. It has actually specific modules dedicated to specific functions, but all of them also serve as storage, and all of them also serve as places where we sleep at night. So it's a multi-purpose base where we're learning how to use space in very confined environments like this, where we're conducting surface operations day in and day out. And it's very important to note here that we're not really engaged in a lot of simulations. Instead, we're just going about our scientific fieldwork in ways that are relevant to Mars, and looking at the way we do things and transposing that to our future on the Moon and Mars. Occasionally, we do simulations where people are locked up, but usually it's, for example, to do a pressurized rover traverse, like a road trip where we simulate a crew being on board a rover, and they would not go out unless they were in a pressurized spacesuit, for example. So we have limited simulation, but generally speaking here, we're talking about doing Arctic fieldwork and exposing our participants to learning how to plan and conduct efficient and productive exploration work on planetary surfaces. So you saw this view maybe earlier, but here's the caption version. We have an airstrip. That's how we come in from Resolute Bay, which is a separate island in the Arctic. We have our base camp here, trails that are well marked, and then a helipad area, waste processing, a fuel depot, and more fuel. This place is currently being used also as a lunar analog, in spite of the Mars connection that it has. One of the places where astronauts are going to go is the vicinity of a large crater near the south pole of the Moon called Shackleton Crater. As it turns out, Shackleton Crater is exactly the same size as Haughton Crater, 20 kilometers in diameter. And where the astronauts are likely to land and explore is actually near the rim of Shackleton, which is sort of similar to where we are set up in relation to Haughton Crater. But look at the topography. The Moon is at the top, Devon Island and Haughton Crater at the bottom. The Moon on the left, Haughton Crater on the right. Gigantic boulders are just sitting there in the landscape, tossed out by this massive meteorite impact event. We also have places that never see the disk of the sun. The sun is relatively low still, even in the summer, and there are places, there are nooks in valleys. We're getting a satellite phone call here. There are nooks and valleys that never see the disk of the sun, just like there are places on the Moon that are permanently shadowed. We also use vehicles to learn how to explore. And then let me show you how similar this place is to Mars. We are studying Haughton Crater on the right and comparing it with craters on Mars and to see how weathered they are. So there's a lot of geology, of course, but also microbiology. We're interested in life in this place. What you're seeing here is called pattern ground. It's patterns that the ground adopts when there are cycles of freezing and thawing of the ground. We think that Mars is experiencing that, at least in the past it has for sure, because the patterns formed are very similar to the patterns that we see on Devon Island, for example. There are also rock glaciers that are creeping slowly over time. A rock glacier is essentially a glacier that has more rock than ice. So it's carrying a lot of debris and dirt with it. We also looking at valley networks. These very mysterious valley networks on Mars on the left have unusual, in fact, exceptional counterparts on Devon Island. And we actually think that these were formed underneath ancient ice covers, both on Devon Island and on Mars, which of course is has completely changed the picture of what early Mars might have been like. Instead of a hot, warm, tropical place, it might have been actually a very cold place all along. There are canyons that we love to explore. Look at that, left on Mars, on the right, Devon Island. Things called sapping valleys. We don't have time to go into the details, but very unique similarities. And in the next few seconds, you're going to become a world expert on gullies. These are gullies of type 1. These are gullies of type 2, gullies of type 3, gullies of type 4. So if you're interested in how gullies form on Mars, and that's an important thing because we think gullies involve liquid water at some stage in their formation on Mars, you're going to be interested in coming to Devon Island to see how they form. And then there's the landscape, of course. The landscape of Mars compared to that of Devon Island. Note that there's absolutely no vegetation. And this is actually a big difference between a place like this and, say, the deserts of the southwestern United States, where as soon as you look carefully, there's actually plenty of plant growth. And that is, of course, in the way of your surface operations. You know, you have to drive your rover around sagebrush. Whereas here, there's nothing to worry about. You just go to the horizon, if that's where you're headed. So the landscape is quite stunningly similar in many ways. This is why we would like to create an opportunity for more people to see this, not in the form of tourism as such, but rather as embedded participants in our project, engage in the science and research that we do, helping us explore this place, draw lessons for Mars and moon exploration planning, and allow humanity to expand beyond our planet. So I'll skip through these other slides, which are all of Devon Island, but the trick was to make you think that it was actually of Mars, to show you how we get there. So this summer, what we did was we traveled from, many of us from California to either Vancouver or Calgary. I personally went through Calgary. And then the whole team met up in Yellowknife, including people coming from the East Coast. And then from there, we flew on a plane to Resolute Bay. And then from there, our project charters small twin otter planes to fly over to Devon Island to our camp. This is the little town of Resolute Bay. So this is the closest community to us. It's about 45 minutes flying time towards the west from where we are on a separate island. And it doesn't have a hospital. It does have a little clinic, but this gives you a sense of how remote we are compared to even regular infrastrucstructure that we enjoy down south. Some years we fly directly to Devon from NASA Moffett Field using military C-130 aircraft. Other years, like this year, we flew commercial, most of us. This is the twin otter plane that flies you from Resolute Bay to Devon Island. So it's essentially a cargo version of a Dash 8 and a very capable plane. Notice the Tundra tires that it is equipped with. In the winter, we put on skis, but in the summer, which is where we generally go to Devon Island, when we generally go to Devon Island, the plane is on tires. And then, of course, there's also the weather, which is both interesting, awesome, but dangerous as well. It's often foggy, and so planes, have to really manage the weather situation before they can do safe landings, both at the point of departure and also at the place where they pick up people. Every now and then we have helicopters to allow us to travel to farther locations on Devon Island. And this is an aerial view of our base camp, where you can see that it is both big and small. It's a little polar research station, but at the same time, it's the largest privately operated polar research station in the world. And so, once again, I hope this will become home to many of the people that you support and engage in space travel. Last but not least, we travel across Devon Island in vehicles. We have two former military ambulance Humvees that are converted into pressurized rover simulators. So a pressurized rover is sort of a planetary RV in which you can travel in shirt sleeves, and then you don a spacesuit to go out for your space walks. So we use these as simulators of such vehicles. And then, of course, we have other heavy-duty vehicles at camp to help us move stuff around, including people. And we have a fleet of ATV. This is our fleet in its more glorious days. It is somewhat smaller today, and we're trying to replace it now with a new generation of electric ATVs in the years to come. But we do go on long traverses in groups, sometimes smaller than this, sometimes even larger, and explore this magnificent site that we have here on Devon Island. The pressurized rovers, the Humvees that we have, are also used for research. For example, we attach robotic arms to them and drive around and collect samples, which we then examine and decide whether we want to keep, in which case we put them in the sample basket, or we don't want to keep them and then we discard them. The buildings at camp are also sometimes transformed into laboratories. In fact, some are dedicated for research and are always labs. But here you are seeing a robotic rover from NASA Ames being readied for a field test, and a biologist who's studying stress levels through the sampling of hormones in our bodies. So on a volunteer basis, participants here can also lend themselves as test subjects in biological research and human exploration research. This summer, this is not the picture from this summer, but a similar team is working on testing a drill that was supposed to be on the Viper rover that NASA just canceled, which is, of course, in our view, a sad mistake and should be reinstated. The Viper rover was going to go look for water ice at the south pole of the moon. It was going to carry a drill to drill into the soil of the moon. So wearing my hat here as a research scientist, not connected to NASA at this minute, I will say that we should restore Viper. But other than that, this drill, the same drill, is also going to go to the moon later this year. We think in the December timeframe on the Prime 1 commercial lander. So again, this is the age of commercial space, and I'm quite happy and proud that we're testing here essentially an engineering model of the first commercial drill that will go to the moon here in the next few months. Finally, the sky's the limit. We test aircraft of all kinds. You can see this is a Mars electric reusable flyer from NASA Langley Research Center. At the bottom left, we are testing a astronaut smart glove, which allows you to single-handedly control a drone in flight, which is quite an important piece of technology that was invented and tested here because, as you know, spacesuits are pretty rigid, and it would be very hard for you to fly a drone using the two gloves and the classical joysticks that you have to manipulate. Instead, we have a single glove. And I'll just wrap up by saying that sometimes we put all of this together into simulated missions and go out with our spacesuits, which are provided by Collins Aerospace, the spacesuit manufacturer that the US has, and learn how to do exploration by trial and error here on Earth. And finally, looking to the greater future, we're also looking at plant growth and how we can sustain humans on other planets. This is a greenhouse in which, for the first time ever, we were able to run it robotically for an entire year and grow. We left one summer with plant trays that were just seeded, and by the time we came back the following year, there was lettuce waiting for us in these plant trays. The temperature was regulated on its own. A beautiful achievement by our partners at the Canadian Space Agency and also the University of Guelph. So this is it. I'll leave it at that. Let me introduce you now to a few colleagues who are here. I'll start with Danica Valone. She's our advisor and soon director of development for the Haughton-Mars Project. Why don't you say a few things about yourself?
Hi guys, Danica, pronouns she, her. I have a fabrication firm in Los Angeles that was the first female queer-owned of its kind, and then transitioned into rapid prototyping for the aerospace business. I now work as designer in residence for UCSD, specializing in bionics and human resilience. So I'm here on a project examining a prototype for universal basic healthcare, or a hospital in a backpack, which we can show you little sneak peeks of, including a modified robotic dog that a la Boston Dynamics style that we've kitted out for this purpose. Another important thing to note, I would say that's relevant, is my team built the largest existing indoor Mars analog landscape, which is actually at Biosphere 2 at SAM, with Kai Stotz and Jim Bell advising. And so now I have experienced the largest indoor and the largest outdoor simulation for Mars on Earth. And both have incredible value, but I can say that it is a staggering experience to be here. And the challenges of the remoteness and the difficulty in getting here is an important, and I'd even say critical part of the experience as a whole. So this is not a place for the faint of heart. It's not your first analog experience, for sure. And it's something to work up to, but I can't recommend it enough.
Thank you, Danica. So let me just walk you around our office. This is our main office tent. We've got some desk space. We have, this is Danica's setup. She's better organized than most of us. We have our stove, which never puts out enough heat. And then here we have Matt Jones, who's trying to escape the camera, but he's our deputy base manager and also our field safety officer. Matt is a firefighter, EMT, but also a computer scientist and roboticist. He works in a quantum computing company in DC and actually lives in Seattle. So want to say something, Matt?
Good to meet you. I love being up here, and I think it's a good project, so hope we can get more people up here.
Okay. This is the Collins Aerospace spacesuit. It's a concept spacesuit for future Mars exploration that is being tested up here. You can see that it has a flat panel here, which allows it to mate with a port in a vehicle or a habitat from the outside. And so it's what you call a Suitport spacesuit. And the backpack, you enter the spacesuit from behind this panel. The backpack swings open like a refrigerator door, and then you insert your feet. And so this spacesuit is hanging outside your vehicle, and it never enters the cabin where you work and live unless you need to repair it. So it keeps the dust and everything that goes along with the spacesuit's external environment outside the vehicle, and you just transfer in and out of it from behind. So this is here a prototype of a Suitport. This pod here and the dog, that's Danica's experiment. But this is the Suitport here where the spacesuit backpack would go. I broke my wrist a few weeks ago in a motorcycle accident, but anyway, don't pay attention to this. The Suitport is what we're talking about here. That's part of the vehicle that would allow the EVAs to take place, and then you come in and mate basically with your spacesuit and your backpack. I'm going to take you outside now. There's more people at camp, but actually most people have left camp for the day. The sun has come out finally. So here we are. Just came out of this tent. Here you are. I don't know if you can hear me, but our greenhouse over there with the solar panels. This is the magnificent Mars-like landscape we have. You're looking at the Starlink through which we are communicating. So that's it. That's our satellite dish. It's amazing. The fortress over there. This is another building. This is the one I just walked out of. And normally we have a large fleet of vehicles out here, but they're all gone for the day. Notice the ground is pretty wet and muddy. That's because we had some rain over the past few days, so things are hopefully going to dry up. And on this side, you have the core of our station. So our station is, as you remember, star-shaped a little bit. And here we are looking at the central part of the base. It's our common area. It's where we have our food. There's a bit of a ramp to access it. All of this could be improved and better adapted for more people to be able to come. Here we have a graduate student,
Hi,
Nicholas.
Hi everyone.
He's from France. Tell everybody what you're doing.
Yeah, so I'm doing some drone imaging to understand how we can calibrate the next drone to do some Mars exploration. And so I'm using this analog to fly my drone and get some pictures of some geological features. So it's really nice, really nice.
Okay, great. Thank you. So anyway, I'm going to show you our dining hall, which is also a storage facility. And yeah, dishwashing, very primitive. We don't have running water quite yet. We used to, but then we're moving this kitchen to this new location, so which is in here. And we don't have the running water yet. Our stove, some kitchen appliances, and then some food, some snacks. This is the snack buffet where you can eat all day long if you wanted to. And some stuff that needs to get out of here actually. So I won't show it to you. But anyway, you get a feel for this place. It's both forward-looking into the future, but also a bit rustic, and with relatively Spartan comfort. Let me introduce you to an amazing person. This is Dr. Carol Stokes. She's a world-famous Mars scientist based at NASA Ames. Carol works on. Go ahead.
Well, mostly I work on search for life on Mars.
Great.
Mostly missions that could do that search.
So what are you here? What are you here for?
We are working with the drill, the Trident drill, that is both scheduled to go on one of the lunar missions, actually two of the lunar missions that have been selected to go to the moon. One of them should go by the end of this year. Another one called Viper has been delayed. We hope it still goes, maybe next year. And that same drill has also been proposed through a mission called Icebreaker to go to Mars to search for extant life. So we're testing the drill in ice-cemented ground.
There you go. Thanks, Carol. Thank you. All right. Well, this is just a snippet of what's going on here. But there's much more to do. And of course, the real star of the place is the landscape, which of course is out there. Yesterday, we went on a traverse to about 12 kilometers from camp. And saw some amazing geology. We flew some drones. Anyway, please find a way to allow more people to come join us and do research and exploration together.
Thank you so much, Pascal. And I was just going to add, as you were going out to show us the landscape, for anyone who might not be seeing the visuals, what we're really looking at is just this expansive, endless view of, I genuinely would think it's Mars if I didn't know where you were. And amongst all of that, just endless, brownish red dirt, as far as the eye can see, there were small white houses that Pascal was going in and out of. to find just all of these amazing scientists along the way, popping out of each and every corner, which I just loved so much. So thank you so much for that fantastic tour.
Thank you.
We have about 5 minutes left here. So we're going to spend the final 5 minutes trying to get through as many questions as we can. Pascal, the first one I see is, how cold is it there?
It's not too bad because we're now in the summer. We come in the summer because that's when there's no more snow on the ground. And the snow gets blown away or melts. And so that's when the Martian look of the place gets revealed. We do occasionally come in the winter, but to fix things, not really to work. So today, for example, temperatures are in the late 30s, early 40s Fahrenheit, and it's not too bad. It is very windy, though. I don't know if you heard, but it's pretty windy. We've got 20 knot winds, so the wind chill factor will be something. But then there are days where it's t-shirt weather. It's very warm. We don't recommend the t-shirt, but it's really windless, and that's the key thing. And then now you have a very nice place to work in.
Fantastic. Next question, similar. Speaking of working there, how many people are living there right now?
So this right now our camp is optimally set up to support 12 to 13 people at a time. Now we can have longer field seasons. This year we have a short field season. We're here for about 2.5 weeks. Some years we have longer field seasons, 3, sometimes 4 weeks, sometimes 5, 6, 7, 8 weeks. It's been rarer in recent times to have very long field seasons, but we could start in July, although we now like to start in August when the ground is as dry as possible. But August gives us only the option of doing 3 to 4 weeks.
It is worth mentioning, though, that it takes an additional 4 to 6 days to get here. So on the front end and the back end. So you have to tack that on to the time you'll be away.
Yeah, it takes almost as long, if not longer, to travel from wherever you are on this planet to Devon Island than it is for you to fly to the moon, which is only 3 days.
Wow. That's really putting it into perspective. The next question I have is from Micaiah, who says, how can we work with NASA Ames and with the Haughton-Mars Project for research proposals? Do you have open calls?
Yes, so we have a website, marsinstitute.no/HMP. Once again, Mars Institute in one word, .no/HMP. And that's a place that describes the project but essentially the way it starts is we used to have a form that people could fill to propose things, but the easiest has been to just have people write to us, email to us and say, hey, this is who I am. This is what I would like to do. Would you be interested? And if we're interested, that's when we ask you to spend time writing a proposal. If it's already work that we're doing with other teams, we might say, that's already covered. If it's work that we're not interested in, and never be offended by that. It's just that we try to be very focused and strategic on doing research that's relevant to the moon and Mars exploration, and of course space beyond. Sometimes people want to come here to study, I don't know, migratory birds in the Arctic. It's very interesting research. I'd love to read the papers about that actually, but it's not something we support. So it has to be about space exploration and humanity expanding into space.
The next question I have is from Zach, who says, do any of the vehicles at HMP have hand controls, or do they require pedals? And maybe to add on to that, do you think there could be a retrofitting for any that would make them more accessible with hand controls?
Yes. So all the vehicles we have hand controls, but do have pedals. I'm thinking the Humvee has pedals, the ATVs have pedals. Although the ATVs can actually be ridden if you only have use of your left foot, because that's where the clutch gear shifter is. So But having said that, we don't feel that we've really thought this through at all at this stage. That's precisely what we hope to get out of our partnership with AstroAccess, is to either retrofit some of the vehicles we have or bring new ones that are more thoughtfully designed ahead of time to allow more people to drive them.
The electric ATV fleet we're hoping for would be able to be controlled exclusively with hand use.
Fantastic. That's so exciting to hear. And I'm looking forward to working on that. So I guess the answer is stay tuned for more soon on that. Okay, we have a lot of questions coming in. I'm sorry we won't be able to get to everyone, but I'm so excited to see all of this amazing interest from our audience here. Danica, or a couple people are asking if there's a way to contact you. If you're willing to share an email address in the chat, feel free. Otherwise, we can connect them through Pascal. But that's a question from Rachel. Thank you, Rachel. And Beth here is asking if you can tell us a little bit more about food and training.
Food and training, yes. So the food, we buy our food usually at the last minute once we're in Canada, but still down south. So when we're traveling north, this year, for example, we bought all our food that we brought up from Yellowknife, and then we put it in coolers, and then we ship all that on our plane, which also has a cargo section from Yellowknife to Resolute to Devon Island. And once it's here, we of course sort it out and store it and consume it. Now, in addition, our camp has emergency food storages where we have enough food supplies for, I think it's about 3-person years. So you could feed 3 people for 1 year. 3 people for 1 year. So I don't know if it comes down to that, and there's some sort of a major global war down south, and we can't get home. We can probably survive, 3 of us up here for a year. Anyway, that's just neither here nor there.
I'll also say that we have some celiacs and gluten-free members of the team that are up here right now, so we can accommodate dietary restrictions. Vegetarians and even vegans are possible. I will also say that each of us have squirreled away some favorite treats and provisions in our bags. So it is.
Did that?
I mean, hypothetically, someone might, not naming any names, but could squirrel away some food in bags.
Yeah. Every trip begins with a personal interview. I mean, I interview each participant, but our Matt, who's our field safety officer, or the camp doctor, when we have a doctor at camp. This year we didn't have one, so Matt is our stand-in for that. We interview each participant and document your specific needs, dietary, but also physical, also any medication you might be taking. And I want to emphasize that our project is not a select out process. It's a select in. In other words, if you really are somebody that we would like to have come to camp and work with us, we will work around your limitations, disabilities, dietary, requirements. We will accommodate as much as we can to enable you to participate. So that's the whole select in approach, as opposed to finding reasons why you shouldn't be coming.
Thank you. Unfortunately, that is all the time we have. So I want to thank you all so much for coming. Pascal, Danica, Sheila, does anyone have any final thoughts or anything you'd like to share before we say goodbye to our audience tonight?
I dropped my email in the chat and I saw that you forwarded it. So by all means, do reach out. I'm happy to continue the discussion.
Thank you so much. And I'll
Thank you, Anna. I'm very happy with this partnership. It's a big, happy beginning.
Absolutely. We are so excited to be partnering with your whole team and have just the opportunity to see a little bit behind the scenes today with our audience. So thank you all so much for coming. Thank you to the very, very busy people in the Arctic Circle, taking the time out of their day to show us around. And thank you so much to everyone for being here. We're really excited to stay connected, and we welcome you to check out the recording of today and share it with your networks, and look forward to talking more soon. Thank you everyone so much.
Thank
care.
you. Bye.